Hello there. So today we are talking about transfer learning. What that means is we take a technique, let's say neural network, we train that model or somebody trained that model with large amount of data. So you get a pre-trained neural network model and then you fine tune it on your small sample. And then this model would be able to use your data and do whatever you are trying to do. In this case, we'll be using an example of text classification. We'll go through the Python code, but in nutshell, this is what's happening behind the scenes. This for this we'll be using FastAI, developed, which is a tool developed by Google. And the advantages of transfer learning is it gives you better accuracy. In my testing, it has given more than 90% accuracy so far. It's very fast compared to training your own model, and also it requires very small data. Maybe a few hundred should be enough. All right, so with that in mind, let's jump into some codes and see how that actually plays out. Okay, so I already have it set up. We are going to import the libraries, including FastAI. You firstly have to install it. So I have already installed it. We'll run it. And then we load some data. I've already loaded it. This is what our data looks like. Let's say it has some texts. In this case, they are selling frame painting for home decoration, and it has a label associated with it, which is household, and so forth. There's the picture box. Again, another painting. So data looks like this. The labels are of four categories, which we see here is clothing and accessories, household, electronics, and books. I'm printing first five observations, which are of household. But the idea is we have text that explains what's going on, and then the model is gonna try and come up with a label for that text, whatever that is. Okay, so with that in mind, I subset the sample to 10,000 observation only because I want to make it fast. 10,000 should be sufficient. Then I look at that. My data has all the four categories: clothing, households, electronics, and books. Then I load this data into an object called text loader, and I put language model to true, and then some other parameters like how many batch sizes I need. You can use it just like this and replace the data frame that you have. Then we're gonna load this object into a language learner model, and then I have chosen AWS LSTM model, which is already available with Fast AI library. You can tweak it to include some other model and go from there. And over here we are actually training a model on language, not classification. The reason being, the classification requires the language model as an input. Okay, so we do that and then fine tune it, which means just change the weights of some neural network layers. It runs and does what it does it thing. Then we save the output of this fine tuning to our hard drive because we'll be needing it in a little bit. Then we again create the same object without the ISLM parameter. So ISLM parameter in this case is false. And then we create an object that will load into a text classification learner. So it would take text classification object that we just created, again the LSTM model that we discussed, and then dropout rate, and we are going to evaluate this model based on accuracy. Then we load this language learner model, and at this point we fine tune our classifier. In the very first run, it gives you 90% accuracy, but we can do better. We are going to unfreeze more layers. In this case, I have unfreeze on all the layers, but good practice is to slowly unfreeze the layers. Anyways, I unfreeze all the layers and then I again fit another epoch cycle and fine tune it. I get 92% accuracy. And then I save this classifier as English classifier, and then we can also reload it. So let's reload it right now. So it's loaded now. And these majority of these text I copied from Amazon because I believe the model has not seen Amazon data. So this is a book from Amazon. Let's see if it classifies it correctly. Yeah, it's a book, and it had the most probabilities, about close to 80%. So model is 80% confident that this is a book. Let's try this one. It's the same thing with a few more information. Again, it's a book. Now the confidence of the model has increased to 88%. Let's try this one. This is, I believe, another book. Yeah, 98%. This is a book. Now, this is not a book. This is some home decor item. Let's see if it finds, yeah, household. And it is 95% sure it's household. Then let's try this one, Mini Cooper. Again, this looks like some sort of a chopper household item, I believe. Yeah, household item, 92% sure. Again, this is handy compact chopper, so kitchen item should be household. Yes, 89% confident in the model. This is again a household item, I believe. 77% confident in the model. Remote control holder again. Now this one. Now this is ant roach gel, which is used for killing cockroaches. Right? This is gonna misclassify it. It thinks it's a book, and I believe it thinks it's a book because there's a killer in there. And if you train the model based on some novel titles which has killer in there, then it's probably gonna think it's a book. You know what? Let's try one thing. Let's remove this killer, and I have not done this before, and see if it still classifies it as a book. Ah, it's still a book. All right, let's get rid of this as well. Still up on a book. Let's see. I also get rid of. Well, I think this one is completely wrong then. And then, so what this shows you that this model is not perfect. There's a 10% error rate, which we saw that accuracy is only 90%. So this is one of the cases where a model is making a mistake. Let's do a classifier of disinfectant, household liquid, and then this is a watch. Now this should, I believe, be electronic. Yeah, electronic, and model is about 38% confidence. See, it would have, it's very close to, model is very close to classifying this as a household item, but by a thin margin, it figures out it's an electronic item. So there are some borderline cases as well. Anyways, so just thought this was an interesting machine learning model or technique where you can transfer the learning from one model to the other, save you time, get you better accuracy, and so forth. All right, and thank you for watching. I appreciate it. Bye bye.